So let's start. It's given that 3 plus, we'll open the brackets, 1 upon 4 into 3 plus 1 upon 4 into p plus 1 upon 4 square into 3 plus 1 upon 4 square into 2p and plus 1 upon 4 cube into 3 plus 1 upon 4 cube into 3p, and this series ultimately goes on and the sum is given to be 8. So let's see what can we calculate by using this. This is 3. We can write this as 3 upon 4. This is p upon 4. This is 3 upon 4 square. This is 2p upon 4 square. This is 3 upon 4 cube, and this is 3p upon 4 cube, and this series goes on. So we'll just see the terms. I'll just take the terms that we need to use. See, this is 3 upon 4, and this is 3 upon 4 square. This is 3 upon 4 cube. So we know that if we write this down here, 3 upon 4 plus 3 upon 4 square plus 3 upon 4 cube, and this ultimately goes on. This is a geometric progression. If we just common out 3 and we leave the remaining terms, that is 1 upon 4 plus 1 upon 4 square plus 1 upon 4 cube, this is a infinite geometric progression. So we can calculate this. The sum for infinite geometric progression is a upon 1 minus r. So this is 3 into a is 1 by 4, 1 minus r is 1 minus 1 by 4. This would amount to 1 by 4 into 4 by 3, that gets cancelled out. So we are left with nothing but 1. So the answer for this series that will contain these 3 terms and the following terms would be 1. So let's pick another series, that is we have 3 as well. So 3 would add, we'll add 3 to this, and this would give us 4. That means this remaining term p upon 4, this term 2p upon 4 square plus this term 3p upon 4 cube, this would continue, and this was given as 8, and the sum for the terms on the left hand side was 4. We'll subtract them on the right hand side, and we'll get 4 as this. So this would be p upon 4 plus 2p upon 4 square plus 3p upon 4 cube. So let me just erase this. Yes. So yes, we can common out p from there, and we were left with 1 upon 4 plus 2 upon 4 square plus 3 upon 4 cube, and so on. And this is 4. We need to calculate the value of p. So if you can see that this series is a combined series of AP, GP. AP is in the numerator and GP is in the denominator. So we'll calculate the sum for that. Just let me erase this and create some space. Yes. Yes. So let's call this series as A. So how can we calculate A? It's given as A is given as 1 upon 4 plus 2 upon 4 square plus 3 upon 4 cube, and so on. Just multiply the series by common ratio, that is 1 upon 4. So we'll multiply this by 1 upon 4, and we'll just slide one term. We'll just leave one place here, and we'll write this from the terms from here, that is 1 upon 4 plus 2 upon 4 square and plus 3 upon 4 cube, and so on. So if we multiply 1 by 4, that is a common ratio, 1 by 4, 1 by 4, we'll get 1 upon 4a, that is 1 upon 4 square plus 2 upon 4 cube plus 3 upon 4 to the power 4. Now just this subtract this equation and this equation. So if we subtract both of the equations from 1 and 2, 1 minus 2, so a minus 1 upon 4a would be equal to 1 upon 4 plus 2 upon 4 square minus 1 upon 4 square plus 3 upon 4 cube minus 2 upon 4 cube, 2 upon 4 cube, and so on. So yes, you can see this, you will get this as 3a upon 4. This would be 1 upon 4, and from here it would be 1 upon 4 square plus 1 upon 4 cube, and you can see there is formation of an infinite GP again. So you can calculate this. What is this formula? I have already told you, 1 upon a and 1 minus r, that is 1 upon a upon 1 minus r. Let me write it down again. A is 1 upon 4, 1 minus r, 1 minus 1 upon 4. That is 1 upon 4 into 4 upon 3, or 3a upon 4 is 1 upon 3. So the value of a comes out to be 4 upon 9. This is a. That means the value of this expression, the value of a is 4 upon 9. So we can write this as, we'll just erase this down. Now we can write uh, the value of a, that is 4 upon 9. 4 and 4 get cancelled. So the value of p is nothing but 9. So this was the answer for this question.